The next sequence operation we're going to look at is slicing. So let's create a new Python program. I'm putting it in the same project here. You can actually put multiple programs in the same directory and it will work fine for what we're doing. And so we'll call this slicing demo.py. And I'm going to, let's start off with a string. So I'm going to say tag is equal to, and I'm going to put in some HTML text here. It's still a string. It's just, this is an example from the book. And so we have between two single quotes, we have a string, which is a sequence. It's a sequence of characters. And notice that because I use single quotes on the outside, that means I can use double quotes as part of my string. If I wanted single quotes in here, I could put double quotes on the outside. So that's why Python treats double quotes and single quotes the same as delimiters for a string, but you can, therefore, if you want to use one inside the other, you can use the alternate one outside. So these are just, everything I'm highlighting here is just their characters. They're part of the string. Because this looks like an HTML, or it looks like a link, this Visual Studio code is treating it like one when you could actually click on this, control click on it, and it would go there. But that's not part of Python. Python just considers this all a bunch of text. And so we're going to do this. We're going to say, you know, if I said tag, let's say a print tag open square brace 9, let's see what we would get. We get the H. Which H is that? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's that first H right here. And then if I said print tag at 30, what would I get here? I get this double quote right here. Let's say I wanted to get this link right here. I want to extract that out of this string. Well, how could I do that? Well, what I can do is what's called slicing. I say tag from 9 colon 30. And this colon means I want a slice. I want everything from 9 to 30. Let's see what I get when I do that. And you can see I got http www.python.org. So I got this part. But we saw that the first character was H. And the character at 30 is this double quote. So why didn't this double quote show up here? In fact, let me do the same thing. I'm going to put 31 in here. Sometimes the best way to figure out what's going on is just play around with numbers and see what happens. And look, now it's brought in that double quote, but that was at 30. But when I put 31, it comes in. So what's happening here? Well, what's happening is that with this is inclusive and this is exclusive. That means that when we take this slice from 9 to 30, it's going to take the character at 9, which is this H, and it's going to go all the way up to, but not include the character at 30, which is this double quote. And this pattern is something you will see a lot of. So if we look at this here, we can see that we went from this H to 30, but this element is inclusive. That means we will include this in the result set, but the double quote here, which is the character at 30, is not included. And so that's not inclusive or exclusive. So inclusive, exclusive. It will include the first number, the element at the first number, but it will not include the element at the second number. Now suppose that we would like this part here. Well, we could do it maybe this way. We could say, in fact, I'm going to get rid of this. And actually, just to make this a little bit neater, we'll say the domain is comma that, so that it ends up looking like this. The domain is HTTP, so that's good. And let's say that we wanted the text. We wanted this part right here. How would we get that? Well, okay, well, let's see if we can find the P. So let's print tag, open square brace. So if that's 30, 31, 32, let's see what's at 32. So P, we got the P, so that's the P. And then 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46. And then we'll look at what's at 46. Okay, got the E. But of course, I need to get the character past it, right? So let me try that with 47. So with 47, that's right here. So now that allows me to say, and you know, you can put the print right in here if I want to, but let's say I wanted that in a variable. So I'm going to say text is equal to tag going from 32 to 47. And then I'm just going to print the variable text. So, you know, a lot of times what we would do is we just, you know, rather than doing everything all in like this one print statement, we can put it into a variable and then just use that variable to display what's there. Indices must be integers. Okay, so, oh, I need this to be a colon, not a comma. Okay, so that's cool. Now we got, you know, the text of the link is, and I'll put that text of the link is Python website. And maybe what I'll do is I'll put a colon here to make it obvious. So great. And because this comma adds a space, I got two spaces here. I'm going to get rid of this space here. And that looks better. The domain is .org. The text of the link is Python website. So again, I'm going to get rid of these. And maybe I'll do the same thing here. I will say domain is equal to this. So I'll put it into a variable, and then I'll display it here. And maybe also put this in, just to make it look neat. Yes, there we go. Domain is this. So I got the domain out of the link and Python website. But let's say this was a different size. What would happen then? Well, okay, because this is still pointing at 47, but now the end of this is increased, that creates a problem. So how can we solve that here so that it can adjust no matter what the size of this link is? Well, we could count, rather than counting from the beginning to get here, see, we got really cool pipe. So it ended up here, and then because these are the number of extra characters are in here, I could try to recalculate that. But another way I could do that is just say this is -1, the A is -2, the slash is -3, and this is -4. So I could instead say -4. So now the end of my slice is determined by counting from the end. And now what happens is no matter how much text I put in here, it will automatically adjust for that because I'm counting now from the end. It is still, this character is the beginning, which is this capital C here. Looks like I've got an extra one. And to the minus fourth element, which is this one. And of course, this last character is not included in the result set. So I always get, no matter what the size is, I always get just the elements between those elements. So that's why Python introduced this ability to count from the end. And it's very convenient for these kinds of situations. And once again, if we look at how this works, 32 is the P minus 4 is this character here. This is inclusive, this is exclusive, so it gets these characters in blue as the result. So I'm going to make another program here. I'm going to call it indexing a list demo.py. And we're going to create a list 0, 0, comma 1, comma 1, comma 2, comma 3, comma 5, comma 8, comma 13, comma 21, comma 34. And we're going to, let's say that we want the 7th through the 10th element. So 0, 1, 2, 3, 4, 5, 6, 7. This 13 is the 7th element. And then we want the last one as well. So we want 13 through 34. How do we do that? Well, if I say numbers, print numbers, and if I go 7, and let's see how many elements there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. If I go 7 through 9, what am I going to get? I want to get 13, 21, and 34. Well, I only got 13 and 21. So 9 is the last element. How do I get this last element out of there? Well, what I do is I say, give me index 10. Now, there isn't an index 10 here, but remember, the last one isn't included anyway. So it's going, so by putting index 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, there's 0 through 9 are the indices here. 10 is pointing off the end. But if I do that, I get 13, 21, 34. So to get the last 3 elements, I can do it that way. So to kind of show what that would look like here, we can see that 10 is off the end, and the last element is this number 34, which is at index 9. But we can get that last one by just indexing 1 additional, and that gets us the last 3 elements. Of course, we can also, we have, what would happen if I went minus 1? So that's an indication of the last element. Let's see what happens if I do that. Well, again, we have the same problem. Remember, it's inclusive, exclusive. So we're excluding the last, we're going from 7 to the minus 1th element, which is 34. So we're going 13 to 34. But because the second element in our slice is always not included, we can't get the last elements. So how could we get there? Well, maybe, we could go to 0. Maybe that would be 1 over. So we'll go from 7 to 0. Maybe that will get me all the way to the end. Well, no, it doesn't. Because we end up getting an empty list. So what's going on here? Well, 0 is actually this element. So looking at this, the 0th element is this one. So what happened is when we went from minus 3 to 0, it said, okay, well, that would be going from the minus 3 element, which is this one, all the way to the end, and okay, that's not going to work. And yeah, so we could also do, we have 7 here, they did -3. If I did -3 to -1, for example, that would give me 1321. If I change this to 0, still doesn't fix it. We still get an empty list. Well, how do we do that? Well, what we do is Python's programmers said, you know what? Let's do it this way. We'll say if you don't provide something. So now we're going from the -3rd element, which is this 13, all the way to, what's this? There's nothing here. Well, let's see what happens. Well, now it's going from the -13th element to the end. So you can read this. If you don't put anything in after the colon, read that as saying, you know what? I want -3 all the way to the end. And so we get so that way we can get from 13 to the end by putting -3 to the end, or we could say from 7 to the end. We'd still get 1321 because 13 is at index 7. So either way, this empty says go to the end. What would happen if we said from nothing to nothing? Well, that just says go from the beginning to the end. So if you put an empty at the beginning, Python just interprets that as, oh, well, we'll start at the very first. So this goes from the beginning to the end. So let's go back to our original indexing demo, actually slicing demo here. And let's turn this into a more interactive program. So actually, let's make a new one. I think it'll be easier. So we're going to call, this is actually off of listing in your book, listing 2-2. And let's say that what we want to do is we want to, given a URL from the user, display just the domain. And what I mean by URL is something like http://www.something.com in the form of that. Let's display just the domain. And so the domain would be this part right here. So how would we do that? Well, let's start off just by saying URL is equal to, and we'll start off with this maybe just to start off to figure out how to do this. And so this is often how I'll figure things out. First we're going to get the URL, and then we need to find the domain, and then we need to display results. So that's kind of our pseudocode. And I'm just going to start with hard coding it so that it kind of stays consistent. So find the domain. So how do we find the domain? Well, let's try to find the first letter first. We want to find this S, and that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm just going to say, first letter is equal to URL, and I forgot what I put. I'm just going to put 11 here, and then I'm going to, for now, print first letter. So, trying to figure this out, we'll just try to do that. And we get S. And okay, so I've got the first letter here, and then I want the end. Well, do I count from the beginning? Do I go 11, 12, 13, 14, 15, 16, 17, 18, 19? Or do I want to figure this out from the end? Well, I'm probably going to want to get this from the end, because if I count from the beginning, if this changes, depending when I get the input from the user, if this changes, it'll make a mess. It'll kind of make a mess. So is equal to URL. And so I'm going to put -4 because I think that -4 will give me this dot. M is -1, 0 is -2, C is -3, this dot is -4. And I'm going to, this time I'm going to print the last letter. And yeah, I'm getting the dot. So those are my numbers. So really what I need is the domain is equal to URL, and then I'm going to make a slice from 11 to -4. And now I don't need these. I figured out what I needed to figure out. I'm going to get rid of those and just print domain. And I got something. Let's see if I put CNM in here now, what happens? I get CNM. Okay, great. So now I know that this is working, and now I'm going to change this into an input. I'm going to get this from the user now. I'm going to say, please enter the URL. And it's always good to tell the user what format you want it in. And then I'm going to run this. And so here we are. I'll put www.w3schools.com. Well, I got to put it in that format, so I also need http:// So it needs to be with that, otherwise it won't work. And I get W3 schools. So, or I'll run it again. And let's see, I'll put www.cnm.edu. Oh, it didn't work because I didn't put it in the right format. I have to put the HTTP. So it needs to be http://www.cnm.edu. I had one too many W's. Let me try it again. So what you can see here is that the format of the input is kind of vital for this to work, but it does work. We're going to learn later how to validate input and make sure that the user inputs things in the proper format. But we can see, okay, this is slicing out what we want. We put in here, run it again. And we put, I'll just put this one in. And yes, it's able to pull it out. So that's how we can use slicing in a program. So now let's look at, we'll go back to this number one here, and let's see what else we can do. Let's put in 0 to 10 and a 1. So now we have 3 numbers. So we have from 0 to, but not including 10, and then there's this mysterious 1. Let's see what happens when we do that. Okay, that displayed the whole list. That's good. Now let's put in a 2 here. Let's see what happens. Oh, look. We didn't get everything. We got 0. We got the second, this 1 here. Then we got this 3. Then we got this 8. Then we got this 21. So what's it doing? Well, what this 2 is the step. What's happening is we are stepping through one element. We're getting every other one, basically. So in this example here, what happened is you can see that the 0, we're going from 0 to 10, which is off the end, which means give me everything, but give me every 1. So we started off with the 0, then at index 2 we got the 1, then at index 4 we got the 3, then at index 6 we got the 8, and index 8 we got the 21, and then we go to 10, we're off the end and we're done. So that we can use this step if we wanted, for example, to get every other one. We can even do things like this. Let's try 3 to 6 and we'll go 3. So this is going from 3 inclusive to 6 exclusive every third one. We got 2. Why do we only get 2? Well, let's run through it. What's it in element 3? 0, 1, 2, 3. That's the 2. That's what showed up. And then we're going to 6. 2. So this is at 3, 4, 5, 6. The 8 is at 6. We're going so 0, 1, 2, 3, 4, 5, 6. So the 8 is at 6, but it doesn't include the element 6. So after it printed a 2, when it added 3, it was actually off the end. It was past the end, so it was done. That's why we only got 1. If we did 10, you would get 2, then you'd go 3, 4 to get to the 8, then you'd do 3 more to get the 34, and then you'd go be at the end and you'd get 3. So you can use this to get every third one if you wanted to. What if we did : 4? So from the beginning to the end, every fourth one. Well, this is the beginning, so we should get 0, then 3, then 21, I think. Let's see if that works. 0, 3, and 21. Yes. So this is kind of fun. One way of playing around with this is put a sequence of numbers together and then just play around with these numbers and see what you get, and write down some numbers in here and then try to predict what will happen. So what if I put 3 and 10 and 34 every fourth one? Well, I think I'll get the 2 and on. I think I'll probably get this 2, and then I'll get that 13. I think I'll be done. Yes. And so you can, what happens if we put 2 in here, and then you just play around with it and just keep switching up numbers in here. And what if I put 2? Well, okay, I'll get the 1, and then it'll be 1, 3, 8, and 21, I think. 1, 3, 8, and 21. So that's how you can test to see if you fully understand it. What if I put -2, 2 to -2, 2? So this one here is at the 2. The -2 is 21, but that's not going to be included. So I'm going to go from here, probably 1, 3, 8, and then I think I'm done. So I think I get 1, 3, 8. Yes. So keep playing with those things, and you will be able to experiment with that. What if I did this? What if I did 8, 3, and I went and my step is -1? So notice now, this is the larger number. We're going to start at 0, 1, 2, 3, 4, 5, 6, 7, 8. We're going to start here, and we're going to go to 2, and it says -1. Well, notice that now we're stepping backwards through the list. The -1 element, or the element index 2, is this 1 here. Notice that it doesn't show up. So even though we're going backwards, it's still 8 is inclusive. So 21 was included. The element index 8 was included. The element at -2 was not included. So it's still inclusive, exclusive, but now we're stepping through backwards. What if we decided to go from 10, which is off the end of the list, to 0, which is at the beginning, and -2 steps? So let's see. Now what happens is that gives us the last one. And then we're going -2 steps, so 34 to 13, to the 5, to the 2, to this one here. And notice the 0 is the last element. That's that one here. It's not included, and we get that list. And then what if we went from 0 to 10 in -2 steps? Before we went from 10 to 0 -2 steps, what happens if you go from 0 to 10? Well, you get the empty set, the empty list. And the reason is because it starts at 0, and then it tries to count backwards off the end here, and it's like, okay, I'm done. So it never even gets to this 10. So if you get these reversed, what you'll experience is you'll get an empty list. And then what happens if we go from the beginning to the end in -2 steps? What happens there? Well, if we go from the beginning to end, does the same thing happen? Well, no, actually, Python's smart enough in this case to figure out that, okay, when you put this colon here, what you really mean is from the end to the beginning. So it will reverse that automatically if you put a minus index, and will count backwards through your list. What if we did 5 to the end -2? So 0, 1, 2, 3, 4, 5. 5 is actually at the element index 5. But we're going from 5 to the end -2. Will it just stop because, well, you know, if we go 5 to the end? Well, no, because it actually also figures out here that what you really probably meant is you want to go from this to the beginning, not to the end. So it, again, this minus will determine whether this empty location here is the end or the beginning. What happens if we say from nothing to 5 in -2 steps? Well, it'll actually figure out that, okay, you want to go from the end to element 5, 0, 1, 2, 3, 4, 5. That's not included, so it's going to be these elements it's going to work with, and it starts at 34, -2 to 13, then it's done. So that becomes very, so those are your slicing operations, and they're very useful to get at pieces inside of a sequence. This will also work, you know, and these slicing operations work with strings, they work with lists, they work with tuples, they'll work the same way. And, you know, the way you learn this is just play around with it, you know, make yourself some kind of a sequence and try to get the elements you want out of there by figuring out what numbers you're trying to get to. And then the other thing is when you're programming this, which, you know, you saw how we built up the code. You know, first we figured out one piece. Okay, where's the H, or where's the S, where's the G? And then once we got that, we figured out our numbers. We got rid of all that other code, cleaned it up, and then got it to work. So you know, a lot of this, the aspect of figuring out programming is break your problem down into small pieces and solve one piece at a time. And then the other thing is, you know, you know, let's say we made that mistake here, and we put in, you know, http://www.cnm.edu, and we saw, oh, I'm only getting one of the characters. What's going on? Well, then we look at the code, and you know, say, okay, that needs to be -4, and okay, there, I got the middle. So now I've got the right numbers. So sometimes you just put your best guess in, see what you get, and then adjust from there, and it will get you to the right place. Thank you very much.